Hey everyone, welcome to 3.2 Part 1, Rolle's Theorem. We're going to jump right in, and it is named after Michael, I don't know how they say it in France, so we're just going to say Michel Rolle from France. And we're going to use this extreme value theorem to kind of introduce Rolle's theorem. And it says the extreme value theorem states that a continuous function on a closed interval must have a minimum and a maximum. And then Rolle jumped in and said, you know what, I've got more to say on that. So here's what I say. He says, let f be a continuous function on the closed interval a, b, and differentiable, and this comes into play later, so it has to be differentiable on a, b as well. So the whole thing has to be able to find the derivative the whole way. If f of a equals f of b, so the y values are the same for both of them, then there's at least one number, c, in ab such that f prime of c equals 0. So let's take a look at two examples here. So here's our function, and we have a and b. The y values are the same, they're equal to d. And so a is here, it goes up, comes back down. There's at one spot in here that the derivative is going to equal 0, and that's at this c. Now c could be over to the right, over to the left. As long as that derivative is 0 at c, that works out. So this one's okay. I put that red star there because, look at this one. You say, well, this one's not differentiable at this spot. It's too pointy, so it means the derivative is not going to be 0. It's still a relative max. It's still a critical point. It's just not going to be derivative equals 0. All right. So that is Rolle's theorem. It's actually not as strong of a form as the mean value theorem, but we're going to start the mean value theorem by using Rolle's theorem. So here is an example. Find the two intercepts, or the two x-intercepts of f of x equals x squared minus 3x plus 2, and show that f prime of x equals 0 is in between these two intercepts. Whoa, that seems like a lot of stuff. Let's just break it down. First, let's find the two x-intercepts. Two x-intercepts are when our original function equals 0. So we can say 0 equals x squared minus 3x plus 2. Okay, now let's say what numbers multiplied to 2 would add to negative 3. We can say that is x minus 2, x plus, yeah, we'll say plus negative 1. There we go. That's how I can get around that. So we have two of those, and we're going to say x minus 2 equals 0, and x plus negative 1 equals 0. So that means x is going to equal 2, and x is going to equal 1. Alright, so we know that those two things are happening. So what we can do is, we know that when x is 2, our point is 2, 0, and our other point is 1, 0. Our x values are different, our y values are the same. So that means we can use Rolle's theorem because the y values are equal to each other. Alright, so now we have to say, show that there is something in between those two intercepts. So there should be something in between. So we want to say, what is the derivative of f of x? Well, we find the derivative, set it equal to 0, will be okay. So f prime of x is going to equal 2x minus 3. If we set that equal to 0 to say, well, we should know that it should happen. We should say 2x minus 3. Add 3 to both sides, divide by 2, and you get 3 halves equals x. And I know all of you know that 3 halves is the same as 1.5. And, yep. So let's just take a moment here and think about this. And we know 1/2 is in between 1 and 2. So therefore, we know that this is in between those two spots, just like Rolle had predicted for you. Alright, so we know that it's at this spot. We could find out what the minimum is or maximum is depending on what the number is compared to the extreme. So we could put in 1.5, we could put 2, and we could put in 1. We know when we put in 2 and 1, it's going to be 0. So if I put in 1.5 squared minus 3 times 1.5 plus 2, if it's a positive, I know it's a maximum. If it's a negative, I know it's a minimum. I'll leave that for you to do, and here is your assignment. Alright, so here it is, and it says for each, hang on, I can't read it up there. It's hard for me to read it when it's actually below me. So for each problem, find the value of c that satisfies Rolle's theorem. Alright, y equals x squared plus 4x plus 4 on the interval negative 3 to negative 1. First thing you want to do is to check, is negative 3 and negative 1, are those the same y values? You got to plug them in and see if that in fact works out. If it is, then you can use Rolle's theorem. If not, then you're not going to be able to do it. So I bet they'll work out. Alright, good luck.